everyone, welcome to our project demo on our AES encryption/decryption accelerator. So we'll get right into it. This is our Python code being executed right now that is currently encrypting data. So this is the plain text we've entered in 32 hexadecimal characters. Since this is 128-bit AES, it'll use 32 hexadecimal characters, which is 16 bytes. So this is the plain text we've entered. It's a pretty easy pattern, and this is the key. This is just two randomly selected plain text and key, and we've entered it into the encryption, and this is the result we've received. Alright, this is the encrypted ciphertext, and now we'll move on to the Verilog code and the hardware. So our prototype does not exactly have any input interface, so you'll have to manually edit the code. So here we've manually added the plain text and key similar to that in the Python, and this ciphertext line is if you're doing decryption, you can enter the ciphertext you'd like to decrypt, but since we're not decrypting, that's for the next section. I've just written down in the comments the expected output we should receive, and hopefully we'll see this. Now onto the DE board here on the display. So here we are displaying 4 of the 32 characters that we would receive for our output, and we can switch which of the 4 of the 32 we'd like to see using these 3 switches down here. So these 3 will basically work in a binary format that display one of the 8 4 character displays that are there in the entire 32 bit. So 4 times 8 is 32. So we'll display the entire thing, but 4 at a time essentially. And we'll be switching it using these 3 switches. And the stop switch over here is to choose between encryption or decryption, but it'll use the same key. So you'll essentially see the input and output if you'd like to. Now I'm going to go ahead and program this into the FPGA board, the DE10 Nano, and it's done. Now immediately after programming, this displays, and we can cross-check it with our expected ciphertext output. So here we have DA77, DA77, and now if I switch it, C8DC, same as here, C8DC. Now when I switch it again, C248, C248. Now we have switched it again, A101, A101. Now if we switch it again manually, so we flick the third one up and these 2 down, we get 3ABC, 3ABC. Now the next one is, A6F9, A6F9. Now I switched it DA93, DA93, and the last one is 5486, which is 5486. Now on to decryption. I've chosen the decrypt option, and I've entered the same ciphertext we had last time. You can cross-check it, as well as the same key. So in theory, we should receive the same plain text as we input initially, which is what we get for the decrypted data, which is just 0 to F and then reversed. These are our 32 characters, so you can see it easily on the display. Now on the Verilog side, I've entered that into the ciphertext, the encrypted data, and we should be getting the same plain text back on our output, the hardware output. So let's see. I'm going to program it, and it's complete. Now here we've selected the decrypt option, which is the switch all the way to the left being down, and as you can see, we have 0, 1, 2, 3, 4, 5, 6, 7. Now if I just swap this correctly, 8, 9, A, B, C, D, E, F. That's our first 16. Now let me just go back. This is F, E, D, C, B, A, 9, 8, and 7, 6, 5, 4, and the last 4 are 3, 2, 1, 0. And that's the decryption done. It perfectly matches the plain text we put in, and that's the demo.